Hello and welcome to today's webinar, Solving the Top 5 Database Monitoring Challenges Fast. This event is brought to you in partnership with Quest and produced by Actual Tech Media. Thanks so much for joining us. We've got a really cool event planned for you today here. There's going to be a lot of education and a lot of demo. Before we get started, there's just a few things that you should know about the event. First off, my name is David Davis of Actual Tech Media, and I'll be serving as the moderator. As always, we want these events here to be educational, and we encourage your questions there in the questions pane of your audience console. You can click on the icon there that says Q/A, and that will take you into the questions pane. Of course, we appreciate all your questions during the event, and we will be doing a live Q&A session at the end of the presentation today. We also have a best question prize for an additional $50 Amazon gift card to help encourage your questions. And before we move on, I also want to point out that we have a number of resources available there for download in the handouts tab. These are special URLs here, starting off with the Foglight virtual lab. If you click on that, that will open a new web browser tab or window in your web browser, and you can try out the Foglight virtual lab for yourself. There's also a link to the Foglight for cross-platform databases landing page and the Foglight Evolve Cloud, so I encourage you to check those out. Finally, at the end of the event today, I'll be announcing the winner of our Amazon $300 gift card door prize. If you're watching this on demand, of course, that drawing has already occurred. The prize terms can be found there in your handouts tab. All right, now, so before we get started, I just want to talk briefly about the constantly evolving data landscape and how it creates a really significant complexity barrier to an organization's database management endeavors. So, I mean, you've heard all the analogies that a company's data is its digital gold and that data is the new oil. I mean, no matter the comparison you make or how you dramatize it, it's really undeniable that a company's data is more critical now than ever before. And I mean, there's just tons of complexities in today's modern infrastructures. Simply understanding all the interdependencies of the critical applications is overwhelming for all of us in the IT group. Applications, they don't work without well-performing computing, high-speed networking, and of course storage. But it's just not the hardware dependencies. There's just tons of software dependencies, identity, API integrations to other data sources, SaaS apps, cloud infrastructures. But really the number one dependency that it all comes back to is the data and the databases that serve up that data. But monitoring and understanding those critical databases is increasingly requiring more and more time. And when there's a problem with the data or the databases, solving it can really be overwhelming and time consuming. And that results in more and more downtime for the applications and lost revenue for the company. Not to mention, the headaches that plague us in the IT organization, those of us who are tasked with managing the databases. There's just too much database, performance issues, too many database performance issues, too much downtime, and these could be rapidly resolved if we had the right tools. And that's really what we'll be learning about today. How to use some of the most intelligent software available to solve your top 5 database performance issues before they can impact your company, your applications, and your job. So with that, let's go ahead and kick it off. I'm excited now to bring in today's 2 expert presenters. Welcome Aaron Newsom, Senior Solutions Architect, and Jason Hall, Senior Solutions Consultant, both from Quest. Aaron and Jason, it's great to have you on. Take it away.
All right, thanks, David, and appreciate the backdrop there as we're going to kind of jump right into today's topic at hand. I put a little agenda up that really is just going to outline some of the challenges that we're going to be discussing today. And I appreciate the introduction again, David. My name is Jason Hall. I'm a consultant at Quest that focuses on database solutions. And given the theme of today's session around database management, we thought we'd break these challenges into 2 primary categories. The first 4 challenges that we're going to discuss are very database-centric, right? So those of you who are DBAs, developers, whatever hat you might wear inside of your organization, The first four challenges are really primarily data-driven challenges. The fifth challenge that we're going to discuss, and this is why we brought Aaron in to help with today's session, is more about the overarching infrastructure that runs your databases. And it could run lots of different things beyond databases. David mentioned a few of the things earlier when he talked about applications and storage and networking, et cetera. But we wanted to really broaden the conversation. Again, very data-centric, but with an acknowledgement that databases rely on hybrid infrastructures, and those infrastructures drive the bulk of your IT infrastructure. Right? So those of you who maybe wear broader hats than just database management, maybe you've got oversight over the entire IT infrastructure, stay tuned for that last challenge that we're going to discuss today around balancing performance and cost, because I think you'll see some value in there. So again, these are the challenges that we're going to discuss today. I've got a mix of introduction followed by some demo, and I hope you walk away from this with a good understanding of not just kind of an acknowledgement or a head nod around the challenges that you're facing in your IT infrastructure, but also maybe some strategies and techniques for working your way through some of those challenges. So we'll start with the overall challenge around, I labeled it centralization, but really it's decentralization of our monitoring infrastructures. Right? David brought up the fact that IT infrastructures have become significantly more complex than they were, several years ago. I've been working at Quest since 2004, and I remember back, again, this is over 15 years ago, walking into a lot of IT shops, and almost every single one of them came saying, we have a standard IT infrastructure, right? Or we have a standard database infrastructure, right? It wasn't uncommon to go into an organization and hear, we've standardized on Oracle. We run our Oracle systems on AIX. Back in the mid-2000s, SQL Server starting to gain steam from Microsoft, and it wasn't uncommon to go into a shop and say, we're a Microsoft shop. We run the majority of our database infrastructure on Microsoft SQL Server. That is extremely rare these days, right? Customers might still have preferences on where they might decide to run some of their databases, but it's rare that you walk into a shop where they even go as far as to say that we've standardized on any one particular platform, right? We've seen customers start to leverage open source technologies where they make sense, right? Platforms like MySQL, MariaDB, PostgreSQL. We're starting to see customers leverage non-relational technologies, MongoDB, Cassandra, cloud-native technologies like some of the databases that run in Azure AWS. And so even in small to mid-sized IT shops, it's not uncommon to walk into them and you start going through their database infrastructure, and they've listed off fairly quickly 5, 10, sometimes even 15 plus database technologies that are under their management. And that in of itself is obviously a significant challenge. And there are lots of reasons why that's occurred. We won't go into too many of the reasons, but some reasons, cost containment, developers choosing databases to service specific use cases, vendor applications brought in that are driven off of a specific technology. But what that's left us with is, to put it bluntly, kind of a mess of monitoring and management, right? The simple question of how healthy is my database infrastructure is a really difficult one to answer, right? You might have to go to some cloud native tools to capture the health of your cloud hosted systems. Open source databases often come with open source tooling of pretty varied maturity. I always tell customers, if you're not paying anything for the database license, you're probably also not paying much for the monitoring infrastructure. And a lot of times you're kind of getting what you pay for on the open source side of monitoring and management. And to compound that even further, some of these legacy commercial offerings, the Oracles, the Microsofts, the IBMs of the world, they really want you to use their own native tools. Sometimes there's a control perspective on that. Sometimes there's a licensing upsell perspective on that. But if you go to a traditional commercial legacy database vendor, Oracles, Microsofts, et cetera, they're going to say you should use our own native manager systems. And what this has left us with is this highly decentralized management infrastructure, right? To answer those simple questions of how healthy is our environment, you've got to go to lots of different places to get that answer. Even just a DBA, right? A DBA who's got to manage, let's say, SQL Server and MySQL and MongoDB, right? Just to name 3 platforms. They now have to jump between 3 different interfaces for the monitoring and management of those database platforms. And it's introduced this significant challenge for IT admins in how to manage these new infrastructures. Most DBAs got their start on a single database platform. Me, myself, I started on Oracle. I eventually became more of a Microsoft expert, but these newer platforms are not as familiar to me. I'm significantly more uncomfortable when you put me in front of a PostgreSQL database as I am when you put me in front of a SQL Server database. And that lack of expertise across an IT organization has introduced challenges and inefficiencies in how we manage this broad array of database systems. I actually was talking with a vendor a few years back, and it was a open source, specifically a non-relational database vendor. And they said their biggest challenge as a company wasn't anything product or feature function related. It was they would go into large enterprise IT shops who just simply said, we don't have the expertise needed to manage your platform. And we're not interested in hiring new staff, right? You could solve this expertise problem by going and hiring additional IT staff, but a lot of organizations aren't in that sort of mindset, right? They want to leverage the existing staff that they have to manage their database infrastructure. But again, there can be a lack of expertise there to do that effectively and efficiently. So with all that, and just to lay out some examples, for example, on a lot of your on-prem systems, and I'll just use like SQL Server as an example, you've got on-prem tools like Management Studio, Azure Data Studio, Query Store introduced in newer versions of SQL Server, each ways to monitor and manage the health of a system. Once you move into Azure, though, Azure SQL, you've got an additional tool Azure calls Query Performance Insights. If you move into Amazon RDS, you've got an additional tool that conveniently is also called Performance Insights, but is a completely different interface and set of capabilities. And this is just a small example, right? Talking about specifically the SQL Server platform, but running in a combination of on-premises-based systems as well as 2 fairly commonly used cloud-hosted providers. Right now, you can exacerbate that problem by introducing platforms like MySQL, MariaDB, Oracle, DB2, and the list goes on, each one really leveraging its own native tooling for managing that system. Right? So how do you fix this problem, right? And there's lots of ways, right? So I'm not going to stand in front of you and say that Quest is the only vendor that can offer you a solution to this monitoring decentralization problem. But really the goal for a lot of IT environments that we work with is to try to centralize the monitoring and management of their IT infrastructure, right? Those in senior management or those on the DBA team want one place that they can go to understand the health of their environment. And you can do that by building and integrating some native third-party monitoring into a single centralized solution. But Quest offers an out-of-the-box product called Foglight. We're going to talk about Foglight a lot during today's session, and we'll be doing a lot of demo of Foglight as well. Foglight provides a centralized monitoring infrastructure that can support the different platforms and the different technologies that we've touched on. Way over on the right-hand side of this slide, you'll see reference to our database platform coverage. And the majority of the most commonly used platforms are supported out of the box with Foglight. We've talked about many of them already: SQL Server, Oracle, MySQL, PostgreSQL, Mongo, Cassandra, and the list goes on. And you'll see some reference below those database platforms to the fact that Foglight's flexible enough to monitor those platforms, whether they run in your own data center on-prem, whether they run in the cloud, either on infrastructure or platform as a service, or where most customers are sitting today, some hybrid of the two, right? Where you're looking to centrally manage your hybrid deployments that include a combination of on-prem hosted systems and cloud hosted systems, but you don't want to have to jump between 2 interfaces to manage the 2 sides. So Foglight, from a coverage perspective, can provide that visibility of health of management of a database infrastructure that IT environments are looking to have covered. Over on the left-hand side of the screen, you'll see reference to the Foglight components themselves. I won't talk too deeply about it, but a couple key takeaways that we often get questions architecturally, so I'll kind of anticipate the questions here. Foglight does leverage agentless data collections. There's nothing you have to install on your IT infrastructure in order to monitor and manage them. In other words, you're not installing agents onto database servers. We remotely connect into a database server from what we call a Foglight Agent Manager service, and that allows us to centrally monitor servers without having to install agents across our environment, which most customers prefer. You'll see in the lower left-hand corner of the Foglight architecture reference to a database repository. This is a centralized repository that we store all of our collected data in. So even if you're monitoring, 5 to 10 database platforms, you'll have one repository of information that you can go to in order to analyze the data that we've captured. And lastly, you'll see in the upper left-hand corner a web interface that we can then view and visualize and manage all of our information from. And this is what we'll be looking at as we get into a demo. All the use cases that we cover are available in the Foglight Web UI. Now, the second challenge I want to introduce here kind of coincides with the first, so I figure I'll talk through both challenges and then we'll get into a demo where we cover both. And specifically, it's about alerting and incident management. The first challenge was really designed around visibility, right? How do I have one place that I can go? A lot of our customers call that like the single pane of glass, right? How do I have one single pane of glass view that I can look at to show me the health of an environment? But there's a second challenge about efficient alerting and incident management, all right? A lot of companies are really striving to really improve how they manage incidents across their business critical applications, right? As customers start to incorporate DevOps, there's an interest in automating much of these practices. But even without a strong DevOps focus, really it's just a matter of efficiently handling incidents as quickly, effectively, and accurately as possible. Right? So there's challenges around, one, just simply getting the notifications that you need to proactively indicate that a server is struggling or a database is struggling. Ideally, to David's point earlier, before the end user notices or before the application suffers some critical outage or lack of responsiveness. But then also, how can we integrate that incident into whatever our IT enterprise's workflows might end up being? A lot of companies have made very strong investments in incident management platforms, where those platforms are designed to track the life cycle of an incident, from the initial detection of a problem all the way through the resolution of that problem, and then maybe reporting off of how incidents are being managed across the environment. And those solutions are great, as long as they can be fueled with the incidents that the teams are actually working on. And so this is really an integration challenge, right? Where a lot of companies are using different solutions for their monitoring and notification than they are for their incident management. And historically, it's been a very manual process where we rely on an IT administrator who's neck deep in trying to solve a problem to remember that they have to then go into their incident management solution and log what they're working on, right? It'd be a lot more efficient if that workflow could really just be seamlessly integrated. So as the IT administrator, or the DBA in this case, is being notified to a problem, an incident's already been created, it's being tracked in the incident management system, and then maybe even that incident management system can synchronize with our monitoring solution so that the monitoring solution accurately reflects the status of the incident. Right? Incident management solutions are great. They're powerful. They provide lots of visibility in an IT org into how things are being managed, but without really tight integration between monitoring and incident management, generally their value kind of breaks down. Right? So let's get into a demo, and I'm going to go ahead and share out my screen here. And once I do, you will be looking at the Foglight UI. We mentioned that web-based console in the architecture diagram, and this is effectively now what we're looking at. And I'll start with that first challenge we mentioned, and I'll outline it as simply as I can, right? That single pane of glass view across the entire infrastructure in an environment, right? And this is effectively what that is. I'm in the Foglight UI. Specifically, I'm looking at a databases dashboard. And this database's dashboard shows me the overall status of every system that's being managed. Each block here, each square in this heat map view represents a server, and the size, color, and placement of that server represents its relative health. Okay, so these small green systems are perfectly healthy in the lower right-hand corner. It's good that I can see them, and I want to know that they're being monitored, but I don't need to know much about them other than being monitored and they're healthy. And then as a server grows in size, changes in color, and moves itself to the left, that's a server that we think needs your attention at a higher level of priority. Right, so I've got 37 databases in this lab, not a huge number. This works equally well if I'm monitoring instance counts into the hundreds, maybe even thousands. The heat map view does a really nice job of showing me which servers are having problems and which is the worst. That last question there sometimes is the hardest, right? I've seen a lot of solutions out there in the market that can maybe take 500 database servers and show you that 20 of them are having problems. And that's a really good start, right? I'd rather have to look at 20 servers that are having problems than 500 that I don't know anything about. But how do I know which of those 20 is the worst, right? And the heat map does a nice job of that. You know, we can always look for the largest or leftist most server in the heat map view and know that that's the one that we think should be prioritized. If you click on a server over on the right, you'll see the types of issues that are being detected. These are login failures that we're seeing to a particular Oracle RAC instance. If we click on a different server, we'll see another set of alarms that are being impacted on that particular system. But again, this is where we can kind of visualize the overall health of, in this case, a database infrastructure. Now, this heat map is one way that we can look at an environment. We also do have this tabular view here. This view is a bit more dense, a bit more data-driven, but a lot of our end users are data people, so they might actually prefer this type of view. It answers that same question of, you know, show me the overall environment with its relative health. I can sort here by alarms, or I can sort here by severity, and we'll see those most critical systems show themselves at the top of this list. But you'll also see some additional detail about, you know, platform and version. You get some uptime metrics here, get some quick visibility into servers that might be down. You get some performance metrics like workload, CPU memory disk, and again, all of these shown across the entire environment. So a lot of times when we talk about visibility, general visibility into health is certainly a strong use case, you know, just that yellow, orange, red perspective on, do I have a server that's unhealthy? But a lot of times the use case does get a little bit more detailed there. Maybe it's more of an inventory management use case. Let me sort all of my database servers by version to make sure that all of my SQL servers have the latest service pack applied. Or let me sort all of my systems by CPU load so I can see the busiest servers in my environment, maybe those that need attention or tuning, or sometimes the opposite. Let me see the lowest utilized systems in my environment. You know, this is a challenge that Aaron's going to talk about a little later in the session about finding servers that are just simply sitting there not really doing anything, right? Maybe those are candidates to reclaim some cost or to consolidate an environment, or maybe even just deprecate a system that's no longer being used. So by having this type of visibility into resource consumption across the environment can be really helpful as well. Last thing I'll mention about this workflow, we've been centered around this all instances tab. Again, that single pane of glass view that a lot of customers are striving for to be able to see the overall health of their database environment. But there's also a use case around single platform visibility. You know, even if organizationally you have 5 different database platforms, you might have a team of DBAs and developers who are only concerned with SQL Server, or who are only concerned with MySQL. So these tabs can serve as filters where you can focus in on a particular platform. You can also create groups of systems by line of business or by tier of application or by application type, and group in that way. And this view can be restricted based on a specific user or group of users to a subset of the database environment. This feature we call user level access here allows you to take a user of Foglight over here in the first column, and then you'll see over on the right, it provides a matrix of which database servers this user is going to be able to see when they log into the interface. This is really powerful because, again, organizationally, you might want this single pane of glass, but you may not want to provide that single pane of glass view to every user in your IT infrastructure. Maybe there's a developer that you'd love to be able to use Foglight, but only for the systems that they develop against. Or maybe there's a SQL Server DBA that you'd like to be able to use Foglight, but only for the SQL servers. So you have that granularity of security within Foglight to maybe take this JSON user here. He's going to be able to see all of the SQL servers and then maybe just one Oracle instance that he's directly responsible for. So I can manage that mapping here, take the Oracle instance, move that to the right, and now when Jason logs into Foglight, he'll be able to use Foglight and all of its capability, but only against the servers that he's specifically been granted visibility to. So that's kind of the usability function here. Now, the second use case I wanted to cover is around that challenge around alerting and incident management. Foglight version 6, and by the way, this is the latest version of Foglight. If any of you have come across it before, you might notice some new functionality that I'm showing today. Foglight version 6 introduces a new capability around alarm templates. And alarm templates specifically address that challenge that I just discussed around centralization of alerting and notification. Within Foglight, we can build an alarm template. We can have as many of them as needed. Some customers just try to standardize on a single template. Others might want to have different templates for different tasks. Here I can see I've got an alarm template here. Actually, I created one just a few minutes ago for the purpose of this webcast. And inside of a template, you can define different platforms that you want included in that template definition. So I've created this webcast template here. I'll edit it. And you'll see I've got host data. Host in Foglight speak is an operating system or a guest or physical server. Maybe we've also got some Kubernetes being managed our environments. We'll include some Kubernetes monitoring, SQL Server, and then some of our SQL servers run on VMware, so I will include some VMware alarms. And just so you can see how easy it is, let's also add in maybe some PostgreSQL. Right? Just click on a platform, add that to the template, and now the template's been modified. Now within this template, we have alarms that are available. And Foglight includes out-of-the-box alarms for each of these platforms that can be leveraged as is. And of course, you can also customize your own alarms if needed. But as an example, within the SQL Server space, we've got over 100 out-of-the-box alarms that range from fairly high-level alarms about the availability of a database server, backup statuses, disk space, scheduled jobs that might be failing, down to pretty low-level performance issues. All right, around maybe a blocking lock or a deadlock transaction or some resource that exceeded some threshold or some statement or job that's running long on a system. Right. So these templates can centrally define the types of alerts that we want to use, the severities that we've configured them with, and the thresholds that those alarms are configured against. And once we have this template defined, we can make it a default in our environment pretty easily so that all new servers added in are configured using this default. Or we can very granularly define, or I should say deploy this template out across any number of targets. All right, so I can take a group of SQL servers and say, I want to use this template as the configuration for a set of SQL servers that are being managed. And maybe I've got 2 or 3 different groups of systems that I want to be monitored separately. Right. Now, alarm templates here handle the alerting side of Foglight. And actually, templates or alarms really serve 2 purposes in Foglight. One of which we've already seen, which is the visibility of the health of an environment in these enterprise dashboards that we've seen, right? So in my heat map, the reason why this server is red and large over here on the left is because of the severity and number of alarms that have been raised. But alarms in Foglight can also drive notifications and incident integrations. And notification is typically handled through email. There's a few other options that some customers leverage in Foglight, maybe sending of text messages. We have some customers that are posting alarms to like Slack or Microsoft Teams channels that their teams collaborate on. So that would be more of a direct notification through email, text, or maybe some collaboration platform. But Foglight also has a variety of integration APIs that we can leverage. And I'll mention one specific API is probably the most common that I see used, and that's that we've got very simple integration with incident management platforms from ServiceNow. You'll see a ServiceNow wizard here. And it's very easy in Foglight to simply step through this wizard, set up some ServiceNow authentication parameters, and once integrated, anytime a Foglight alarm raises that matches one of the alarms that you've decided to integrate, it will automatically create a ServiceNow incident for you and even assign it to who Foglight is defined to assign that incident to. So if a SQL Server problem is detected and in Foglight, you've mapped that alarm to a ServiceNow operator, that user is automatically assigned this database problem that Foglight detected for them. And there's even kind of a two-way synchronization that can happen. So if you're working on the ServiceNow incident, you close out the incident in ServiceNow, Foglight will notice that that incident has been closed out and then synchronize its status with the alarm that Foglight has raised, so the rest of the team can see the alarm cleared and see how it was handled. Now, ServiceNow is one platform that we integrate with, but there's dozens that we can integrate with. We've got similar integrations with platforms like PagerDuty, Remedy, and there's also some just ad hoc APIs that we can reference. Foglight has a very flushed out REST API. We can send SNMP traps out to target third-party systems. We can run custom scripts in response to alarms. So generally speaking, anytime a customer has come to me and said, hey, Jason, can Foglight integrate with X? The answer is almost universally yes. It's just a matter of mixing and matching the APIs that Foglight can call with which APIs are available on the receiving side, and usually either a command line script, a REST API call, or an SNMP trap can satisfy the wide majority of integration requests. So those were the first two challenges that I wanted to discuss. I'm seeing a lot of questions come through, so I appreciate all those questions. I'll try to get to some of these here as we go through the rest of the demo and certainly at the end of the call. Appreciate all of your questions. The third challenge is actually probably the one that's most near and dear to my heart. And it's the challenge I've kind of titled "The Database is Slow." But really, it just boils down to the challenge at diagnosing database problems that are reported with little to no context, right? Now, we've already showed you the list of Foglight alarms. So ideally, you're notified to problems and very specific problems with context, right? You get a notification that says there's been a blocking lock for more than 5 minutes, right? That's an issue that most DBAs are comfortable getting in and solving. But the challenge often is we don't get that level of alerting. What we get is an email in our inbox or an IM in Microsoft Teams or a phone call from an application developer who all they say is the database is slow. And what do we do with that, right? As DBAs, as data professionals, that's a really difficult thing to start diagnosing. Part of that challenge is because you often rarely get much detail, right? When was it slow? Well, sometimes customers can't answer that, right? The developer just says, I don't really know when the problem started, but it seems like, for the last couple hours, it's been a little bit sluggish. Well, what does couple hours mean, right? A lot of times we don't even get something as simple as, what was slow? Are you staring at an hourglass in your application? Are you running a query through Power BI? So that context can be a bit tricky, right? If you're just getting the database is slow, what does that actually mean? Like, what is slow, right? The other challenge here is slow doesn't really mean anything, right? That was always my biggest challenge when I was a DVA managing frontline systems is what does slow even mean? Is it slower than normal? Has it always been slow, but you're just now telling me about it? Was it fast this morning and now it's less fast? Right? These sorts of things are all really important for diagnosing problems, but without that context, it's really difficult to even know where to start, let alone, attempt to solve that problem. And then even if you can get that context, right? Even if you're fortunate enough, right? And this is maybe a best case scenario is that an application developer or a user, sends you an email and says, hey, Jason, this particular SQL server was slow. It's been slow for the last 15 minutes. This morning I tried to run a report and it took 30 seconds. But over the last 15 minutes when I run this report in Power BI, it's taking more than 5 minutes, right? That would be an ideal incident, right? Because I've got context, I've got timings, and I know what was slow. So that's a best case scenario. But now with that information, I might have to go to 3 or 4 different locations to start to diagnose what's actually causing it, right? Is this a resource problem? So do I have to go into like Task Manager or Perfmon or Activity Manager and SSMS, right? If this is a query, do I have to go look at Query Store? Do I look at DMVs? Do I have to start a trace? If I started a trace now, that's not going to capture what was running 15 minutes ago. If this is like a cloud native system, is the problem on network latency? Is the problem on VM performance? Is the problem within the cloud infrastructure due to my billing tier, right? There's all different kinds of places I might have to go to start to wrap my head around what's causing this slowness that's been reported. Right? So with that kind of in mind, I like to focus on not really the breadth of Foglight, but the depth. And you know, we often get kind of general questions from customers around, you know, what makes Foglight unique, right? There's hundreds, if not thousands, of monitoring tools out in the market, Foglight being one of them. What is unique to Foglight when compared with products from vendors X, Y, or Z? One of the things that makes Foglight unique is what we've already talked about, right? That breadth of coverage, the fact that we can support over 10 different database platforms in a single solution. There's some vendors out there that really focus on single platforms. There's some vendors out there that might cover 2 or 3 of them, but Foglight in general covers a pretty wide range of database platforms, wider than most competing vendors. But on top of that breadth of coverage, there's also depth, right? It's pretty easy. Well, I don't want to say it's easy, but there's some vendors out there that provide monitoring, and they will tell you, we can monitor any database that you want us to monitor. But if you look at what they do for each individual platform, it's very high level, right? Maybe it's just simple uptime and simple response times, right? So they can monitor 20 different database platforms, but they only really scratch the surface on what's happening within that platform, right? In Foglight, we focus on both breadth and depth, and this use case is one that I like to highlight more on the depth side. I'll choose SQL Server as an example here, but there's a similar use case here for any of the platforms that we could be covering. And specifically, I'm going to drill into one SQL Server instance here. Let's say this one has been giving us some headaches. Now, there's a few features I want to highlight before I even get too deep, and it goes back to that context challenge. There's a nice feature of Foglight we call baselining. And every vendor has got some definition of baseline. Foglight's definition of baseline is effectively what is normal on a system, right? So as we monitor an environment, we're collecting data, we're storing that data, and then we're analyzing what we've captured so that we can come up with this perspective on what is normal for a given database server. And it's not just a general average, it's what's normal for a particular time of day, day of week, even monthly time ranges if they exist, right? So, you know, what's normal for this database server between 1 and 2 p.m. on a typical weekday in the last week of the month, right? I'm pretty sure that's what today is. So all those time ranges can factor into this normal calculation, and that is what Foglight stores as a baseline. And baselines are used for a number of reasons, but just very specifically, let's say I see some type of resource utilization, like CPU seems like it's a little high. Your next question often is, well, is that normal for the system during the time range that I'm looking at? And baselines can very quickly provide that context. Here you can see a trend graph of CPU on this system. The shaded region is what's normal during the time range that I'm looking at. The line is what's actually been measured. Now, actually, a few hours ago, I saw a pretty nice spike. We'll go and diagnose that in a minute or so. But even just over the last hour, I can see that my workload is a little bit higher than it normally is. Maybe not enough to be super concerned, but those little spikes in CPU that we had a few minutes ago, that was about 80%. It looks like it spiked to, and that's higher than is usual for this particular time range. So that's really helpful context, right? I know this database server is doing something that it doesn't normally do. And I'm going to diagnose that type of problem by looking for an anomaly, right? Let's find out what this database server is doing that it doesn't normally do. That's a very different diagnostic path than if I go and bring open this baseline analysis and say, it looks like the server is just doing the exact same thing it always does, right? So I wanted to kind of show you baselines there. They're going to show up in a lot of different places as we go through this workflow, but Right on this global view, you can provide that baseline context just by simply holding your mouse over a chart or a graph to identify whether that resource consumption is normal or not for a given system. Right? Now, if I drill into this SQL Server, each of these platforms that we monitor has a way within Foglight that you can manage and look into query performance. Right? On SQL Server here, we call this workflow here SQL PI. That PI stands for Performance Investigator. And this is where I'm going to come anytime I want to have insight or provide guidance into the performance of SQL statements running on a system. Right? Now, I could spend a full hour just on this workflow. Of course, I'm not going to for time reasons. But I just wanted to show you that it's really easy in Foglight to take a particular time range that I'm getting complaints over. Right? Now, hopefully, Foglight already alerted you to this problem. But even if it didn't, if a user complained about performance over the last 4 hours, we can come into PI, we can isolate that 4-hour time range, maybe we can zoom in on a spike that we've seen and isolate a particular time range that I want to understand performance over, right? Once I have that time range isolated, we then have a process that we call dimensional analysis that you can leverage to drill down by database, by program, by user. And at each level, we can view aggregate performance details, as well as identify the top SQL statements running and their relative performance. Right? And performance is shown in a few different ways. We've got response time metrics here. We have wait statistics. We have resource utilization metrics. So depending on the context, right? And hopefully you've already got that context. If we're looking for the longest running statement, we can look at response times. If we've noticed our CPU spiking high, we can sort by CPU. But depending on what that context is, we can drill down and identify the SQL statements that are causing the problem or the slowness that we're facing in the environment. Right? Once we get down to those statements, there's even some further depth that we can provide. There's a really nice comparison workflow here. It's one of my favorite features in Foglight because almost every time we drill down on a SQL statement, the next question a customer will ask us is, well, how did that statement run yesterday? Right? Again, hopefully we've got the context where a user says, everything was running great this morning, but it's running terribly now. Well, you can actually do that exact comparison in Foglight. You click compare. We've got the source of our comparison at the top. We've got the target of our comparison at the bottom. Maybe it's yesterday. And now over on the right, we get a side-by-side perspective of today versus yesterday and what's different about performance. All right. So we have this really nice comparison facility. Now, oftentimes, the root cause of problems that we find in an environment is a change. Right? We used to have, and again, I don't want to date myself, but it was pretty often when I talked to customers, 10 plus years ago and asked them about change control, they would say, well, we've got very rigid change control policies, right? We only deploy changes to our IT infrastructure once a quarter. And even then, we've got to present before a review board. We've got to get those changes signed off on. And then only then, once a quarter, we're going to push changes out. Now, there's some environments where that still happens, but the vast majority of environments that I come across are much more agile than that, right? We've got developers pushing changes through your DevOps pipeline that could hit any time of day, maybe even multiple times of day. And any one of those changes could be what causes an issue in a given environment. And so Foglight does some really nice things around what we call change tracking, where you can identify changes that have impacted, in this case, a database environment. These little bubbles here indicate changes that have occurred. And we're going to show you what's changed, but also allow you to correlate that change to some impact on performance, right? Maybe we saw some big spike here a few hours ago, and right before that spike, we saw that an execution plan of a query changed, or a schema object changed. Maybe we added an index thinking it was going to improve performance, but it didn't. Or maybe we changed a configuration parameter to downsize a VM because we didn't think it needed resources when it actually does. Right, so these types of changes would show up in here. You'll see the change and then also measure what its impact on performance might be. Right. So all these use cases, again, I'm really just scratching the surface on some of these diagnostic capabilities, but what I really wanted to highlight is some of the depth that Foglight provides, not just platform coverage, but also for a particular database environment, how deep can it go? And really that's useful again for those dreaded, database is slow type use cases that so many of us have to get involved in. You're likely going to have the information and the workflow needed to solve those problems and hopefully solve them fairly quickly. I often use the term like 3 mouse clicks in 30 seconds is as long as it may take you to go from the database is slow down to some query that's causing a problem with a deep understanding of why it's causing that problem. So that's kind of the diagnostic use case. The last use case I want to cover is actually it's a simple one in writing. It's a difficult one in practice, but it boils down to enterprise reporting. And we've talked about this somewhat already in terms of the decentralization of monitoring, but I find it goes much beyond that and was really worthy of its own bullet here. And that's specifically, how do we get data out to those users that need it, right? Business decisions are being made about our IT infrastructure, sometimes with little or inaccurate or simply decentralized information, right? Customers are having to decide what platforms can we leverage, what resource consumption are we seeing, what availability metrics, like SLAs, for example, are meeting or not meeting to our business users. On the cloud side, how much are things costing us, right? Can we save money? Where are we spending too much money? All of these use cases really boil down to reporting type use cases, right? And Foglight has a lot of reporting that you can do, and there's a lot of sophistication in that reporting. Aaron's actually going to show you some examples as he gets into his section on performance and cost. But the idea that Foglight can centrally monitor so many of these platforms then makes it possible to perform enterprise reporting on top of the data that's been captured, right? And there's a lot of out-of-the-box reporting that comes with Foglight, and you can certainly always run those out-of-the-box reports just by stepping through a wizard and deciding that you want the report to be run and then deciding who you want to share that report with. Right, so out-of-the-box reports are available in Foglight, and they're going to service a lot of use cases, specifically use cases around inventory management, capacity planning, et cetera. But we also have reports that you can customize. So, the idea is, and I'll kind of talk you through what I was going to show as it decides whether it wants to cooperate, that there's a drag and drop workflow in Foglight where you can build your own reports and dashboards, right? And so you've got access to the Foglight data model. Maybe there's 3 or 4 different KPIs that you want to present to senior management from your database environment. Maybe those KPIs are around availability or capacity or performance. And so using that drag and drop designer, you're going to be able to put those dashboards and reports together. Dashboards can be viewed interactively inside of the UI, or they can also be scheduled and automated to be delivered to whoever might want to see the data. So this enterprise reporting use case is a very popular one, especially for those large-scale organizations managing lots of different platforms and hybrid infrastructures where they don't like the fact that they might have to go to some 4 or 5 different tools to get the reports they need. You can actually generate those reports directly from Foglight itself. I'm going to have to restart my browser, but this is probably a good time to pass it off to Aaron. Aaron, if you want to take control, hopefully you can, and I'll let you finish the last topic.
Yeah, sure thing, Jason, and I appreciate that. And I'm going to go ahead and introduce myself. My name is Aaron. I am also an engineer at Quest, just like Jason. We both focus heavily on this specific product that Jason has been demoing to you, which is our Foglight product. Jason, however, really focuses on customers that are running database-centric environments, and we call what I do more infrastructure-centric. And the reason that we kind of added this topic in here along with the databases is because Foglight also includes a number of tools to help you optimize your environment. So using that same tool that Jason has been demoing to you already, Foglight, I'm going to show you a couple integration points where Foglight is helping you optimize your infrastructure environments. And by optimize, I don't just mean for performance, which is obviously a very hot topic, but also for resource allocation purposes and really cost management overall. I keep saying the word infrastructure. Some of you are probably wondering, what does he exactly mean by infrastructure? I'm really just talking about the systems that your databases, your applications run on, and that could be on premise or in the cloud. Or maybe you have applications that span hybrid environments, and Foglight is going to monitor all that. Now, when Jason was showing you the database performance, and you saw those lists of database instances from the different database types, some of you may have noticed that over in the right-hand column, he had a CPU, memory, and disk metrics, and you could see the performance of those resources right there. What that's really showing you is that Foglight is also monitoring not only the database metrics, and we pull those metrics directly from the database API, but we're also monitoring the OS, the underlying infrastructure that that database runs on. And because we're monitoring the underlying infrastructure, whether it be VMware, Hyper-V, Azure AWS, Google Cloud, Kubernetes, or whatever platform those things are running on, you're going to be able to uh, further leverage that information, not only for performance, but what I'm going to show you here, which is optimization. So optimization really includes a number of different things. Right now, I'm looking at a VMware environment. You can see here in the upper left-hand corner. And in that VMware environment, we're on the Optimizer tab. Along the top in this toolbar, you're going to see a lot of the different areas that we can focus and optimize for, whether it's recommendations that Foglight is going to make for CPU, memory, and storage, or being able to do a bit of cleanup in your environment, like abandoned VM images, snapshots that are hanging around, zombie VMs, like Jason mentioned, maybe systems out there that are not really doing much. They're not, maybe they're spun up, but not really doing much. Being able to identify and clean those up. And by clean up the resource allocation and optimization and follow the recommendations that Foglight makes, what I mean is you can select those over here on the left-hand side. And then at the top, we have reclaim buttons that allow you to actually have Foglight go out and perform those tasks of making the optimization. And you'll see that, you're seeing it here in VMware. You'll also see it in Hyper-V, in the cloud platforms, and Kubernetes, and some others as well. Now, you'll also notice, for those of you who are paying close attention, up here in the upper left-hand corner, we have a indicator of how much you can save per month. So this is now talking really about cost. If you're going to follow Foglight's recommendations, we're going to show you how much you can save per month. And that always leads to a conversation about, well, how do you exactly know how much you're going to save per month? And that is a tool within Foglight that is called the cost director. So those numbers, that number that you saw there in the optimizer, it's coming directly out of this tool within Foglight. Same tool, same tool that we're monitoring databases and optimizing VMware and Hyper-V. We're also looking at the cost and how do you optimize that cost. So you'll notice in the toolbar across the top that we're looking at on-premises and cloud. And I'll also point out that this really does cover the Kubernetes cluster cost as well. If those are running on-premise and in the cloud, those Kubernetes costs are built right in here as well. Down at the bottom, you're going to see some really nice information about cost breakdown as far as your Azure, AWS, and cost of your Google clouds, as well as your on-premise. And you're also going to see this big chart in the middle, cost projections out into the future. Now, we're today in the middle of October, but you can see that over and to the right, that Foglight is breaking down the cost of your environment, and it allows you to see those kind of spread out into the future. So that was kind of an overview. Now, we also allow you to get very granular on where your costs are going. We allow you to take your different subscriptions from the cloud vendors we support. You can assign those to what we call organizations and business units that are defined within Foglight. And that allows you to see which organizations and business units within your company are using the most cost, who's taking the biggest slice of the pie of the overall cost. But the cloud cost dashboards allow you to see really what your billing is for each of your tenants that you have that you're monitoring. You can look back into the past and and get more information about what you spent in the past. And also, you can see here, starting from this bar chart here, November out into 6 months into the future, Foglight is going to predict what your spend will be for the various cloud platforms based on the trends of what your cost is. So it's a really great tool for not only seeing what your actual costs have been, what the cloud vendors have billed you, but looking out into the future. And you can see here in the lower right-hand side that we also break down those costs in the cloud, so you can see how much you're spending on storage versus bandwidth versus virtual machines or public IPs or anything else that you're going to have in the cloud. Now, one of the other things that I wanted to point out, and I am trying to leave some time for questions at the end here, is one of the features I see that our customers really appreciate is for your Azure, AWS, and Google. And really, this is more generally and broad. It's not necessarily databases that you're running, but really anything that you're running in the cloud. You can go ahead and set a monthly budget for what you expect to spend, or really what your budget is for the different subscriptions from the cloud vendors that you have. And then, of course, that alerting and incident management that Jason was pointing you to, all of that ties right into this cloud cost, on-premise costs, your Kubernetes cost as well. You will get notified if you, excuse me, are on track to exceed those budgets. You will get notified of those. So not only are we collecting all of that information, giving you a dashboard where you can see how to optimize your resource usage, but we're also giving you a tool that you can use to budget how much you intend to spend on each of those platforms. Now, just to kind of finish up here before I pass it back to Jason and open it up more generally to Q&A, we started in a VMware environment where we were looking at the Optimizer tab, and we're looking at some of those recommendations that Foglight was making for how to better allocate your resources and cost management for your on-premise. And we're going to end right there in the Optimizer tab again, except this time now we're looking at cloud optimization. So all of those tools that you saw on the toolbar for VMware, we have a number of those tools available here on the cloud side, where Foglight is really going to be actively looking at your hybrid application infrastructure and telling you where you can optimize, not only to save money, but also improve your resource allocation and performance of those platforms, whether they're running databases or really any other applications. So that is a bit on the cost management. Jason, I appreciate you passing it over to me. Hopefully you got your browser situation figured out there. I'm going to pass it back to you, and hopefully we'll have a few minutes for Q&A here.
Yeah, thanks, Aaron. So let me push to the last slide here. So I'm going to just kind of introduce to you something that's available. David actually introduced this to us at the very beginning, but for anyone that might want to try out Foglight, there's a really nice option we call our virtual lab. You can access the link here. I believe it's in the handouts page of the web session. This lab is somewhere that anyone can go to. It's a hosted Foglight deployment. You can request a login to it, and pretty quickly you'll be granted access. And it will allow you to try out some of the things that we've shown you during today's session in our own hosted sandbox type environment. There's a handful of database servers out there, a handful of cloud and infrastructure components, so you can kind of get a feel for how Foglight offers. If you want to take that next step to try out Foglight in your own environment, there's also a link there where you can request a download. There's a fully functional trial that's available that anyone can install on their own infrastructure. But honestly, the virtual lab is a great place to start, given the lack of need to install anything, and really just check out Foglight for yourself. So I definitely recommend that as a next step for anyone who might want to learn more. There's a few questions that I've seen that I'll just kind of attack as quickly as I can. There was a couple questions about data being fed into other solutions, so just kind of general integration solutions. I saw a specific reference to SIEM type tools, SIEM. In general, yes, Foglight can integrate into just about anything through either a REST API call, a custom scripted action. So for example, a SIEM tool can likely make a call into Foglight to extract data, or Foglight can push data out. So generally speaking, those types of integrations are all going to be possible. There were a couple other questions about let's let's see, does Quest offer Foglight training? Great question. So we do, and there's a variety of methods for that training. We actually have an online series we call Foglight Skills 101. If you just Google that, it'll likely bring you to the site, Foglight Skills 101. We've had about 40 of these over the past year. Few years. These are designed to be training type sessions for existing customers through Foglight who are really just looking to maximize their investment. Some of them are targeted more around installation and configuration of Foglight. Some of them more targeted at how to use Foglight to do specific things in an environment. So if you go to Foglight Skills 101, throw that into Google, check out the site, you'll find a lot of on-demand kind of archive trainings. We do also offer some more formalized training through our professional services organization. So if you've got yourself or a team of individuals that you'd like to put through more of a classroom style, kind of one-on-one type training session, we can coordinate some of those activities as well. Certainly reach out and we'd be happy to connect you with the right resources there. Those were two of the most common questions that I saw. David, did you see any other questions that you think are good to tackle?
Let's see, there's maybe just a couple other questions we have time for. I know we're running out of time here. What about Foglight reporting on database slowness in Azure SQL? Is that possible?
Yeah, definitely. So Azure SQL is one of our supported platforms. We actually support any type of database running in Azure SQL. Those could be managed instances, elastic pools, single database. One specific thing that we do for Azure SQL that's especially useful is we'll tell you whether your slowness is simply the result of just under-provisioned hardware, or in other words, I like to say, you're not paying Microsoft enough. There's a few scenarios that could come up where your queries are slow just because you haven't bought enough DTUs or you haven't licensed enough vCores, and so that's actually what's bottlenecking your resource or the query performance. It's not that the query couldn't run faster, it's just you might need to pay more to Microsoft to get it to run faster. And then, of course, with that information, you can make the decision on whether or not it's worth doing. But yeah, all flavors of Azure SQL are supported with some nice capabilities around, tracking compute consumption and what sort of volume you've had there.
Excellent. Yeah. And I know we're running out of time here. Just kind of final question. How should folks get started? Is it the virtual lab and the evaluation? Are those the two best options?
Yeah, virtual lab is where I'd probably direct you to first. Again, just a good kind of low barrier to entry way to try Foglight out on some fairly common use cases. There's a link in the virtual lab to request more information. That'll get you in contact with a resource request if you want to learn more about maybe doing a trial or license agreements, or how the software is licensed, what the cost is, things like that. So virtual lab is a great place to get started. You don't have to reach out to anyone to take that next step. And then if you'd like to learn more, of course, there's ways to get in touch with us and move forward.
Excellent. Well, there's so many great questions out here from the audience. I'm afraid we didn't have time for all those. We'll have to get back to those electronically, but we do appreciate all your great questions. I encourage you to check out the resources there in the handouts tab as well. There's a link right on the top to the virtual lab, also Foglight for cross-platform databases, and Foglight Evolve Cloud. Aaron and Jason, it's been great having you on. Thank you for the presentation and the great demos as well.
No problem. Appreciate it.
You're welcome,
everyone.
David. Thanks for having us.
Thank you so much for being on, and thank you to Quest for supporting the event. Before we go, of course, I want to announce the winner of our Amazon $300 gift card door prize. This is going out to, drum roll please, Bob Lalone from Minnesota. Congratulations, Bob Lalone from Minnesota. We will reach out to you, and we'll also be reaching out to our best question prize winner as well. Thank you to everyone who joined us on the webinar today. I hope you learned a lot, and have a great day. We'll see you next time. Bye-bye.